So vector product are not commutative. In dot product or scalar product, we saw a dot b was equal to b dot a because there was no issue of sign. That was a scalar thing. What is this property called? This is called distributive property, and the vector product follows distributive property if you follow the order strictly. That means the order sequencing here is ABC, you keep the same sequence ABC. If you do that, the vector product follow distributive property. Now there is no as such formal proof that I can offer to you, but you can take side instance and you can verify this. You take I cap, j cap and k cap like A, B and C, and you verify this. You do I cap plus j cap and you do the cross product of the resultant with the third unit vector, and you do it part by part and you see whether you are getting the result or not. I'm leaving up to you to verify this. Please do that. Now as we had theta in the case of dot product as cos inverse something, we'll have the same thing as sine inverse something, coming straight from the definition here. And this will come in will be very handy when you know both the vectors and you want to find the angle between them. You can get it from here. And certain simple things, the maximum value of A cross B would be A into B. That would happen when sine theta is 1. That would happen when theta is equal to 90 degree. And this is in complete contrast with in the dot product. The maximum value was when theta is equal to 0 degree. Right? Because of the difference of the function. There it was cos and here it is sine, and that is very obvious. And the minimum value would happen. The minimum value, what will be the minimum value of A cross B? The minimum value will be 0, isn't it? Now, it won't be 0, the minimum value would be A into B minus A into B when theta is equal to 270 degree. But the problem is this is 90 degree and this is 270 degree. When you take 270 degree, actually in taking the vector product, the theta or the dot product or cross product, the theta that we take, that is the smaller of the two angles that the vectors make. Now if you are looking at 270 degree, that is not the smaller angle. The smaller angle is 90 degree. So you don't take 270 degree. The value of sine theta is -1 at 270 degree, but you don't take 270 degree because the smaller angle is 90 degree. So it is not allowed to take the larger angle. You take 90 degree, and when you take 90 degree, sine theta is 1. So you never get the cross product of A and B as minus AB, because we have taken the convention of taking the theta as the smaller of the two. So there is never a situation exists in which you take the angle as 270 degree, because you always have a smaller angle as 90 degree, and in that case A cross B will be AB. So it turns out you will not have minus AB as a value of cross product. So the minimum value in that case would be 0, and that would happen at theta is equal to 90 degree. Theta at 0 degree. Okay. Now the self cross product A vector cross A vector, that would be mod of A into sine theta. Theta being the angle between the two vectors. They are the same vectors, they are parallel vectors, the angle between them is 0, so their cross product is 0. So the self cross would be 0. Self dot we saw would be A square, because of the difference in there you had cos function, here you have sine function, because of that. Okay. So I cap cross I cap, this is going to be 0. Fine. J cap cross J cap, this is going to be 0. K cap cross K cap, this is going to be 0. Fine. Okay, I cap cross j cap. What is this going to be? I cap cross j cap. Suppose this is the axis that we have. Okay, x, y, and z. We define it like this: x, y, and z. Now this is I cap, positive x-axis, and this is j cap, positive j-axis. I cross j. So you have to curl your right palm from I to j. So curl from I to j like this. Thumb is pointing upwards. So this is the direction of I cross j. And the magnitude will be 1 because magnitude of I is 1, j is 1, and sine theta would be 1. 1, 1, 1. So magnitude of this is going to be 1 and direction is upward. So it will be an upward unit vector, which is k cap. The upward unit vector is k cap. So I cross j we will write as k cap. Similarly, you find j cross k. Can you find j cross k? This is j and this is k. J cross k. Curl your right palm from j to k. Do that, please. Don't just sit back and listen. Move yourself, push yourself. From j to k, you have to curl your right palm. From j, if I go like this, I'm going from k to j. I have to go from j to k. So this is my thumb direction, and this is the direction of I cap. So j cross k would be I, and similarly k cap cross I cap. K cap cross I cap. This is k and this is I. So going from k to I. If you go like this, you're going from I to k. You have to go like this, from going from k to I. If you're going from k to I, your thumb is pointing in the direction of j. So k cross I would be j. This is important and you have to be very handy with this. It comes in order, as you can see. I, j, k. I cross j is k. J cross k is I. And k cross I is j. So you're doing I cross j, the answer would be the next one, k. If you're doing k cross I, it would be j. If you're doing j cross k, it would be I. They always be in order, I, j, k. I cross j is k, j cross k is I, k cross I is j. Now if you reverse it, if you're not doing I cross j, you're going in the reverse order. You're going from j to I, j cross I. Now let's see what is j cross I. This is j and this is I. If you're going from j to I, then it is in negative direction of z axis. So it is minus k. So if you're just reversing the order, we have I cross j, we are going clockwise. If it is I cross j, it is k. J cross k is I. And k cross I is j. If you just reverse the order, j cross I, it will become minus k. You have to see if it is you are getting minus k. If you make k cross j, it will be minus I, and I cross k will be equal to minus j. Spend few minutes in familiarizing yourself with this. You have to develop speed in writing this. You don't have to think. You have to think now. You don't have to think when you are solving the problem. Think now, practice now, so that you get speed. Okay. Now, if we have vectors, just as we did the dot product of them, let's do the cross product for them. If we have a vector is equal to ax I cap plus ay j cap plus az k cap, and we have a b vector as bx I cap plus by j cap plus bz k cap, and we have to do a vector cross b vector. Then let's do a vector cross b vector. A vector is ax I cap plus ay j cap plus az k cap cross bx I cap plus by j cap plus bz k cap. Now vector product follows distributive property. So let's do the vector product using distributive property. We'll have ax I cap having the vector product with each one of them term by term. Ax I cap into bx I cap. We have seen I cap into I cap 0. So this 2 will give our vector product 0. Ax I cap into bx by j cap. I into j is k. So you have, what you have is ax into by j cap. Now ax I cap into k cap. The k cap into I cap is j cap, but here we are having I cap into k cap. That would be minus j cap. Followed? So you can open rest of the bracket on your own. Can you do that? Please do. Just like we did for ax, you do for ay and you do for az. And when you do that, this is what you're going to get. This is what you're going to get at the end. Like we have an expression for dot product, you have an expression for cross product here. Now there's one more thing, because it looks a little larger term to remember. I mean, if you have two vectors given like this, you'll have to remember this formula to solve it quickly. So, and it won't be very easy, or it won't be desirable to remember this kind of thing. So what we have another very innovative way of representing this expression, and we have also that remembering that will also be very easy. So what we do is, we represent this expression in a different form. We don't want to remember this whole thing. What we do is, this is called the determinant form of the vector.